All right, today's lesson is 4.3, triangle congruence. There's your belt work, so go ahead and write it down on a piece of paper, and then come on back for your lesson. All right, there's the lesson for your table of contents and also your objectives. So please pause and make sure you get that information down in your notebook. Today we're going to talk about congruent triangles a little bit further. So as a review from last week, congruent triangles means that all angles are congruent and all sides are congruent. So I have congruent parts of triangles that are congruent to each other. Today we're going to take that a little step further and talk about congruent statements, which details the corresponding angles and sides of congruent triangles that are congruent. So the difference between last week and this week is last week we talked about triangles, they were given congruent to us. There was a congruent statement made at the very front end of the problem where it said the two triangles were congruent. For example, I can say that these two triangles are congruent because it was given to me. Well, today we are going to learn about how to prove triangles are congruent if we didn't know that going in. So that's the difference between last week and this week. Before we get started, we need to talk about included sides. So an included side is the side that is shared between two consecutive angles. So please take a moment and pause the video and get this in your notes. All right, so the included side is going to be the side that is shared by each of the angles. So I have these two angles and these two angles, and this side is shared by those two angles, and you will always see the marking of that side in between the two angles. For example, if I go to the second image over here, there's my two angles that I'm considering, and this is the included side in between. The marking will be in between. The side is shared by these two angles. An included angle is similar. An included angle is when two lines meet at a common vertex, and the angle formed is called the included angle. So this goes way back to the beginning where we talked about two rays making an angle. Well, here I've got two line segments making an angle. So this statement says, the included angle says that the angle created by the two line segments is the included angle. So for example, I've got these two line segments here. This would be the included angle. All right, so go ahead and take a moment, pause the video, and see if you can fill in the diagram at the right. I'm going to get you started on the first two, but then you should be able to finish up the last two on your own. So the angle included between line segment AB and line segment CA. Well, if I look here at my markings, I can see that they are both sharing angle A, or point A, I should say. So I could tell from here that they are going to be sharing angle A. That's one way to tell. The other way to tell is to go ahead and label your line segments. So line segment AB is going to be this guy. And line segment CA is going to be this guy right here. So the included angle would be the one created by those two line segments, which would be angle A. So we get angle A either way. The included side between angle A and angle C, so the included side between angle A and angle C, well, we talked about the included side being the one that is shared, and we also talked about it being you mark it in the middle, in between the two angles. So go ahead and finish up the diagram, the last four examples, and then come on back when you're finished. All right, today we're going to talk about 5 congruent statements to prove that triangles are congruent. So I would recommend you definitely need this information here. Oopsie, sorry, I forgot my pen. You definitely need this information right here. I would certainly, absolutely, positively draw the diagram. Because a lot of times when you go back into your notes, you're going to want to see that visual, which is going to be a real quick reflection of what you learned. Basically what side, side, side says is that if I have 3 corresponding sides, so that means I have this side and this side, those two correspond. These two correspond with each other, and also this side corresponds with this side. So I've got 3 sides that correspond to each other and that are congruent. So this is congruent to this is congruent to this, and this is congruent to this. Simply, I know that because they are marked the same. So then I can say that the triangles are congruent overall because of side, side, side. All 3 sides are congruent. Congruent statement number 2 is side angle side. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the other triangle, then the triangles are congruent. So just like that, I'm looking at my markings. So I've got a side here that's congruent to a side here. I have another side here that has a corresponding congruent side over here. And then I have an included angle. Okay, the angle created by those 2 sides. So if I have this situation that is between two, or this relationship between 2 triangles where I have a side and an angle and a side and an angle and a side from another triangle, then I can say that my triangles are congruent because of side angle side. Now keep in mind, I want you to keep this in the back of your mind, that if the triangles are congruent, and if I've proved that the triangles are congruent, that means that all the other corresponding parts are congruent. For example, this 3rd side over here has to be congruent to this side over here because the triangles are congruent. I could also say that this angle and this angle are congruent, and I could also say that this angle and this angle are congruent. Okay, so keep that in mind. Keep that in the back of your mind, because that's where we're headed with this. All right, congruent statement number 3 is angle side angle. So I have 2 angles and an included side. So if I have an angle here, angle B is congruent to angle Y, and angle A is congruent to angle X. Then notice that I have a congruent side that is for both of them, that is the included side for both of them. And notice that the side is between the 2 angles. Okay, both side marking is between the 2 angles. So when you have this situation, you can say that the triangles are congruent because of side angle side. I'm sorry, angle side angle. Angle side angle. Congruent statement number 4 says angle angle side. So similar to angle side angle, except now the side is not the included side. It's going to be one of the other 2 sides. So for example, I have these 2 angles. I've got this angle congruent to this angle, and this angle congruent to this angle. And notice that my side is not between this time. So we have a different labeling of angle side angle, also known as AAS. All right, the last congruent statement that we have is hypotenuse leg. And that hypotenuse, right here, this word implies that there is a right angle. Only right triangles have a hypotenuse. So I have a right angle that's congruent. I have the hypotenuse, which is the side opposite the right angle, which is also congruent. And then I have a 3rd side that has a congruent partner over in the other image. So if you have a situation like that, you can say that the triangles are congruent because of hypotenuse leg. All right, just to sum it up, here's the 5 methods that we can prove triangles congruent. We have side, 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 where all sides are congruent, or I have congruent corresponding sides. I have side angle side, where I have 2 sides and the included angle, side angle side. And then I have hypotenuse leg, which we just got done talking about, right angle and hypotenuse and one of the other legs. And then angle side angle, where I have 2 angles in the included side. And then I have angle, angle, side, where I have two angles and a non-included side. So there's two different ways down here at the bottom. I want to point this out. It's really important that you cannot prove triangles are congruent. The first one, let's talk about this one first. AAA. So I want to tell you why that doesn't work. If I have an equilateral triangle where I know all the angles are 60 degrees, and they have to all be 60 because equilateral means that they have to be equal to each other. They still add up to 180, they're all 60. All right, so say I scale that thing, or we're going to call it dilating. That's the word dilate. We're going to use that in geometry and in the near future. Say if I dilate that thing or blow it up like 3 times as big. The sides are still congruent. The angles are still 60 because they have to still add up to 180. But the sides aren't congruent anymore. So angle, angle, angle is not a way to prove that triangles are congruent. The second way that is not a method to prove triangles are congruent is SSA. But here's a better way you can remember. I'm going to reverse the order of those letters, and I know it's a bad word, but you won't forget it now, I'm pretty sure, because nobody ever does. So you cannot use the letter sequence angle, side, side, or side, side, angle to prove that triangles are congruent. All right, I'm going to go ahead and stop there for today, and we will see you tomorrow. Have a good day.